All right, so today I get to start doing, they're all fun, but today especially is going to be, the beginning of, fun lectures. Let's go ahead and, actually before I do this, all right, pause. There we go. So you may have noticed if I go to Canvas, it does, which I'm not going to do today, or don't need to do right now. If we go to Canvas and we check our website, our Canvas page, we are bereft of any additional material. After all, there's basically, as I mentioned, we kind of hit the end of our curriculum for the most part. So my plan is this week I'm going to cover this week's topic, which is regular expressions. Next week, I plan on going over some more technical stuff, boring but useful things, such as how to handle nested lists and things that Professor Fiore, who teaches 1068, has said. I think my students need more. I need to be more familiar with this material. So that's the plan for the next 2 weeks. This week, I'm going over my special topic, my personal topic that I go over, and then the next week is going to be going over some more topics, and then after that we will continue on exam review for both the final and exam 3. Now, this topic is kind of sort of extra credit, kind of sort of. Let me explain by that. This topic is going to be the big topic that's on exam 3. Technically, exam 3 is optional because, if you're happy with your grades, you can drop exam 3. You can just take a 0 and drop that as your lowest, right? Because exam 1, 2, and 3, we take the top 2 of those, drop the lowest grade. Similarly, on the final exam, there's going to be 7 questions. That's how I've done it since I started with COVID. And I found that this is a pretty decent way to handle my final exam. There will be 7 questions, each worth 20 points. They're larger questions, but they're broken up with rubrics to say, okay, can you do this subsection of it? And I will tell you the topics of them. For instance, I can tell you right now, one of them is a list of list questions. One of them is reading a file and determining, data from, which row is the best based on a criteria. Another question is something that I will not and have not taught in this class, where I give you the documentation for a task and then tell you the documentation for something built into Python, and then you proceed to use it. There will be a Monte Carlo, and I'll list them all out. One of those problems will be along the lines of the issue we are going to talk about today. We are given a file. I want you to remove everything of some that meets a criteria from a file. Okay? But regular expressions will be the topic of exam 3. Now, regular expressions are kind of interesting because, regular, that's not what I needed, regular languages. Because you typically deal with this in automata theory, which in this school is it's a 3,000 level class. Some schools is a 4,000 level class, and it gets into really weird stuff in theoretical computer science and formal language theory. Regular language, also called in theoretical computer science, a finite state automata from automata theory. And automata theory is this wonderful thing about that talks about, hey, let's we've got these finite state machines, then we've got push down automatas and Turing machines. Turing machine being an abstract model for a computer, right? Basically, it's a machine that represents everything that a computer could do. And this is tied with what we call Turing complete languages, which are basically every single programming language is a Turing complete language, but it is a formally mathematical definition of a language. And because it's math, and because it's a mathematical definition, we can do things like prove stuff with it. That's useful because then you can prove, are things possible in a language or not, right? Now, this all gets to very complex kind of stuff. For instance, a regular language, right? We can say the empty language null set is a regular language for each A in sigma. A belongs to sigma. Look at this nonsense, right? See, here's the thing. This is what you have to be exposed to in order to be taught regular expressions in a normal computer science context. And I say, what? No, because regular expressions are some of the most useful things are there, and you don't need to know the nifty language behind it. I love this stuff, but they use Greek symbols, and everybody knows using Greek symbols makes everything infinitely more complicated, right? More confusing. Why not both, right? So these things are great, but again, like when we talk about these Turing machines that have right here's the formal definition of a Turing machine with a 7-tuple M. Like, again, it's so let's see if I can go for complete, if it comes up with complete, right? Turing completeness, right? So there's all this kind of stuff in automata theory about these stuff. Most languages are Turing complete. You don't need to know any of this stuff. The stuff you would normally get exposed to in automata theory, or if you're more fortunate, if you just mess around with stuff for a while. Okay, everything we're going to learn about is built into Python using the RE package for regular expressions. Also, and possibly most importantly, every single programming language has a library that's going to use the meta language we're going to learn today. Also, pretty much a lot of stuff. Let's see. A lot of stuff that we learn. Okay. A lot of stuff that we use, like the search function in a text editor, especially in a programming context. If I help, it has these symbols: find, match case, whole case. Use regular expressions. You can find this in Excel and in Word documents as well. They're everywhere if you look for them. They're extremely powerful. So let's just simply go with the top level description. What are regular expressions good for? And the answer is supercharged finds, supercharged searching through text. That's what regular expressions are good for. Looking for patterns in text, okay, and specific patterns. So we're gonna start today though with a story. So for so we have a lot of people who are not who did not grow up in the U.S. in this classroom. So for the benefit of those people, can somebody explain what Florida Man is? Yes.
Because Florida has a lot more permissive laws about sharing arrest records and things like that.
Yes.
A lot of news stories come out about some of the more insane criminal cases in Florida and things like that. So there's sort of been a bit of a stereotype about the average Florida person is drugged up on meth and driving out to Florida and things like that.
Yeah, no, it is exactly right. There is these propensity of Florida, which is the peninsula, the southernmost, southeasternmost state in the United States, is this peninsula, very tropical climate, let's say, very, very warm. And a lot of people end up moving to Florida for various reasons, and you get a lot of different people there. It's a very large state in terms of the number of people who live there. And there's a lot of news reporting that simply says Florida Man. And if you look at news stories, I mean, we can do that right now. Okay, might be a bit unsavory, but Florida man. Let's go ahead and look at that news. Florida man faces. Let's see. Florida driver films Florida biker for making written threats. Come on, boring. None of the wild stuff. Okay. Oh, there we go. Idling Rolls Royce ghost from valet. What? Oh, yeah. Florida man arrested with meth in northeast Iowa. Just all these terrible things where it just simply says Florida man. I personally have asked ChatGPT to give me a explanation of what Florida man is as Florida man. So here's what it says. Yeehaw, partner. Now let me tell you about me. I'm Florida man, the legend, the myth, the barefoot symphony of chaos in the gas station parking lot. 1 minute I'm wrestling gators in a kiddie pool full of mud and dew. Next I'm getting arrested for trying to marry a dolphin. But it's not what it sounds like. People say I'm unpredictable, but I call it creative problem solving. Police reports just don't carry the nuance of trying to rob a Wendy's with an alligator. Living in Florida is like existing in a fever dream, where the sun fries your brain just enough to make reasonable decisions sound boring. But anyway, Florida, like New Jersey, is one of the states we love to make fun of in the U.S., whereas actually the state that we should be making fun of is Mississippi. Mississippi knows why. So, yes.
I grew up in New Jersey.
Yes, and everybody makes fun of it. And everybody, it's one of the two states that everybody makes fun of, right? They have there's a Futurama bit where they're searching for an apartment and they're looking for an apartment in New York, and there's all these terrible apartments, like one's underwater, and then they go to this completely normal apartment. And he's like, "I'll bite. What's the catch?" And he says, "Well, technically we are in New Jersey," and it cuts to going, "Not one livable place." So there's. Because the joke is that it's New Jersey and therefore it's unlivable. Because people make fun of New Jersey. Okay, but and like I said, what we should make fun of is Mississippi. We have a saying in the South, "Thank God for Mississippi," and if you know, you know. So anyway, Florida man. As you said, which is normally most students don't give me that explanation right at the beginning, which is why is Florida man a thing? Why is Florida man a thing? And there's a lot of different reasons that are kind of hypothesized for Florida man, right? If we go to the actual Florida man Wikipedia page, right? Popularized in 2013, right? Because of the way news headlines are typically written, they can interpret the subjects of the article, all single individual known as Florida man. And yeah, the Miami New Times, who I guess would have a vested interest in defending the honor of their state, would claim that the freedom of information laws in Florida make it easier for journalists to acquire information about arrests. And and that's what we're going to focus on a bit today. There are these government freedom of information laws in Florida that do make police records and things of that sort very easy for news reporters to dig through, which is honestly pretty cool, right? Specifically, it is the policy of the state that all state, county, and municipal records shall at all time be open for a personal inspection by any person. Public records, right, and then it goes into those kind of transactions. Now, there's obvious carve-outs for things like social security numbers, right, or specifically like some really private information. Okay, I'll get into why social security numbers are important later today. But anyway, Florida man is just kind of really funny, and it's just one of those fun memes. There's memes about Ohio as well. Those are pretty good memes. So anyway, but what we're focusing on is the Freedom of Information Law, and this is going to take us back to to a recent presidential election. No, not that one. Not that one. We're going back to the 2016 run up to the 2016 election, which is the specifically the Republican primary during 2015 for the 2016 election. Now, I have to give my typical caveat here. I'm not picking on any particular party because of my own political leanings. I feel like I have very obvious political leanings, but I do my best not to try to alienate anybody in my class because of my personal political leanings, because I guarantee I disagree with all of you on pretty much anything. I believe that arguing about arguing with you about your political positions and taking certain stances makes the act of arguing makes you a better debater, essentially. So I obviously have my own positions. So my caveat is here, I'm making fun of this particular politician because this is the most recent case. And no, this is not the politician you're thinking of, even though I said 2016 election. No, we're talking actually about the original front runner in the 2016 election, which was... Anyone? I know, this is ancient history at this point. So before Donald Trump entered the the Republican primary, there was a very long lead up during 2013, 2014, as to who the natural candidates for the election would be. The Democrats pretty quickly solidified around Hillary Clinton, whereas the Republicans, for the most part, solidified around one other particular presidential dynasty. No one. Oh, yeah. No. That's an independent who caucuses with the Democrats. So the Republicans coalesced around Jeb Bush, for the most part. Jeb Bush, and at this point, again, it's, enough time has passed for you guys to be pretty young when this was going on. Jeb Bush is the older he's the older brother of the former President George W. Bush and the son of the former President George H.W. Bush. So, pretty big family. Wouldn't you notice this? He was the governor of Florida. I wonder why that might be relevant today. So anyway, Jeb Bush was the governor of Florida from January 5th to 1999 to January 2nd, 2007. Now, this was actually a very interesting time to be in politics from a computer standpoint, because that's when the internet started being really a thing that normal people would use and could use to communicate with the government, right? That was so basically during this period that he was in power, things like sending emails to your representative, to your senator, to your governor, to either, yell at them in the age-old American tradition of being able to complain, or asking for help was a good way, or cutting through red tape. And you might be wondering, well, what kind of things would speaking directly to a representative or senator or governor be useful with? And I'll give an example. There are issues where that do crop up, that do happen. They're rare, but they do crop up, and really the only way to get around them, because they are so rare, is to go and basically yell at somebody who can then shout down the ladder to say, solve this problem. One issue is that if you're dead, or rather legally dead, this occasionally happens where a filing happens and you accidentally get declared legally dead. This makes applying for a job rather difficult because you're dead. You're obviously impersonating this person with some very, very convincing documents. But you're dead, and the government says you're dead, and no, you can't be alive. Wow, you really roped an entire fake family into this. Wow, you're really devoted to this entire act. Yes? Like the paperwork has been filed saying you are dead.
But you're still alive, so how
Names are not unique. Names are not necessarily unique. The filing error might happen. You might have been legally dead for a bit and the doctors messed up somewhere. It's a very niche thing. Or somebody's running a scam on a life insurance scam. It's actually so interesting thing I learned from a DEF CON lecture. It's actually rather easy to register fake births and rather easy to write out the coroner forms and get a coroner's license to say that this person died. Yeah. It's, anyway. But, like, again, the easiest way to get by this kind of nonsense, okay, is to, like, reach out to a person in the government who can shake the bureaucracy a bit. Okay? So long story short, people do send emails, and some of these emails have very, very identifying, very strong identifying information that you wouldn't want necessarily to be public. Now during this time, he was called. I believe he was. Does it not have it? He basically adopted a lot of technology and embraced, the use of the internet in his governmentship. There were a lot of stuff with technology that he embraced, and he liked the whole being open about his communications and stuff like that, and being easy to reach via his email. He embraced this stuff fairly early on, so kudos to him there. Now, what he wanted to do is that he wanted to run for president eventually and become the Republican candidate in the 2016 election. Now, as part of this run-up to this election, he decided to get in front of a whole bunch of transparency stuff and show how transparency was by releasing a ton of emails because they figured they would be accessible via request because of I believe they'd be accessible because of request because of, again, Florida is very permissive with their stuff. So rather than saying, hey, and basically he did the thing and said, hey, look, there's no skeletons in my closet here. And he released all his emails. The issue is that, as I previously mentioned, some information should not be released, especially if it's personally identifiable information, such as social security numbers, which led to this fun headline from The Verge. Although it was often described as although some more other websites did describe it as Florida man doxes 1 million people. Not really like that. Oh, yeah, Florida man strikes again. There's the sub. So Jeb Bush dumps emails, including social security numbers of Florida residents online. So Jeb Bush, a rumored 2016 Republican presidential candidate. So again, this was fairly early on. Notice the date it was published, February 2015. Everybody knew he was running for president, even though he didn't declare, because there are certain financial reasons you don't want to necessarily declare about expenditures, about whether or not you're running. American campaign finance law is wild, okay? Anyway, in the spirit of transparency, I'm posting the emails of my government shit here. Some are funny, some are serious. Some also contained, some I wrote in frustration. Some also contain email addresses, home addresses, phone numbers, and social security numbers of Florida residents. Now, for those of you who are not in the U.S., you probably have a national ID from your nation of origin. This is a very common thing. U.S. is a bit weird because we have about like 50 separate governments who may not want a national identification, and the passport isn't really a national identification, nor is it meant to be. But every U.S. citizen does have a social security number, which was never meant for this identification purpose. And in fact, my social security card says, "Do not use this for identification purposes." And everybody uses it for identification purposes anyway. So that's its whole other topic. But simply put, know that it is a very fragile piece of personal identifiable information. So here's some personal emails. You can read through them. Other emails, this has been redacted by the website itself, says RE blank, social security number blank. And again, we don't want to see these in our emails. This is bad to see in our emails or to see online dumped. This is, and again, I'm not making fun of Jeb Bush because I think there's anything particularly funny or I'm being mean-spirited about this particular politician. I didn't actually say this. The reason I'm picking him is that this is the most recent example. When something of this nature happens again, I will proceed to make fun of that politician. Yes?
Why would you even ever email your
Again, trying to say, hey, this is a particular person, or I'm trying to cut through this. This is cutting through red tape and saying, I'm establishing that this is a person. You think communicating with the government, you're thinking to yourself, the government already knows my social security number, which they do. They already know your social security number. Well, maybe not that piece of government, but in theory, the government knows your social security number because they're the person who gave you the social security number. Anyway, this is basically saying, hey, this is a person who is good. He's been good for the past 7 years. Please help this person. Hey, please cut through the red tape here for getting this child into surgery because the American healthcare system is a nightmare when it doesn't work. It's great when it works, and it's a nightmare when it doesn't. So again, social security number of this patient, of the mother of this patient included here, their health insurance ID, which is probably less identifying, but, again, cell phone numbers at here, which, not necessarily the worst thing to harvest, but still, kind of annoying. Right, whereas these kind of public numbers are not because again, these are business things that you could look up pretty easy. Anyway, so the question we ask ourselves today is, suppose I've got 1 million emails I need to suddenly release because I'm working on a presidential campaign and my candidate wants to release all of his emails. But some of them contain personally identifiable information. How do I go about removing this personally identifiable information? This is the prompt for Florida Man. It also gives me an excuse to talk about Florida Man in class and occasionally make fun of New Jersey. Just FYI, for full disclosure, I grew up in Georgia. So, so there wasn't much making fun of New Jersey. It was making fun, again, of Mississippi. And allow me to explain that. Mississippi routinely ranks 49th/50th in every single category in the U.S. that you, or first in the categories that you don't want to be ranked first in, like infant mortality, or 50th in education level. It's not, Mississippi's a bit of a mess. So, let's see. So let's go and get into the actual meat of our lecture. There's these tools we have called Regex. We're going to use a website called Regexer at first before we integrate it with Python. But let's look at the Wikipedia page. A regular expression, shortened as Regex or Regex. I've never seen the latter except on this page. But sometimes it's called Regex or Regex. Honestly, I don't know. Everybody will understand what you're talking about. But the idea here is it's a sequence that we use a sequence of characters to match text. Here is basically a regular expression that we've been given, which is which is this regular expression R open bracket. Let me zoom in so everybody can see this. So everything in between the slashes is the regular expression. Ignore the G, that just kind of is a special command that you might use in some cases, and that's not really relevant for Python. Okay? So this is the important bit that I highlighted. R, open bracket, and then A-E-I-O-U, close bracket. And what this is basically saying it's an R, I'm looking for the pattern R followed by one or more vowels. So you can see where it's been highlighted in this text. And these, again, are very, very powerful tools that have been used. DFA, yep. So we can, DFA, a regex processor translates these, deterministic thing, and the resulting DFA is run on the target text string. So basic concepts, it talks about this. There's this, and again, here's that whole formal language theory I was talking about at the beginning, where basically we have this empty set, this literal string character, given a regular expression, all this. We don't need to know any of this formal theory in order to use them. And the reason you want to use them is because they really help. They really help. For instance, if we look at the if we look at the Java docs for the string, right? This is for Java. Doesn't matter what version it is. And we look at the replace all function. So replace takes in, let's go ahead and look. Replace takes in an old character and replaces it with a new character. Replace a character sequence with another character sequence. Replace all takes in a, what's this? A string that with the variable name regex. I wonder if that's a hint as to what it's looking for. It's looking for a regular expression. And so these regular expressions are used in, basically are natively supported in pretty much every single programming language. They are extremely powerful. So using this is not just applicable to Python, but in general applicable. So we will use this website, Regexer. I'll type it out here, regexr.com, which I find very good for just constructing and playing with regular expressions. Again, the regular expression is basically everything between these slashes. So you can use. So let's go ahead and start. You can use regular expressions just like you would use the find function, in anything, like in a web page where you use Control F, right? Control F. I'm looking for reg, and it finds reg. Or if I look for all instances of the letter E, and I hit highlight all, right? You see that, right? That's just the find function that's built in, right? So you can use a regular expression engine like this. I can also hit a flag to say it's case insensitive, but let's just go, we're computer scientists, we're programmers now. Let's go ahead and say case insensitive, or it's case sensitive at the moment. So you can use this, you can use it for more complicated stuff like da, right, where it's looking for the string DA. What makes it useful is the ability to add some kind of wildcardness to this entire aspect. The ability to do more complicated searches. For instance, there's some special commands we can use, such as /w. The slash represents, hey, it's an escape character, just like we saw in Python, right? In Python, we sometimes need to use escape characters like /n to represent a new line. Here, we are using slash to represent, hey, let's look out, there's a special character coming. /w says, hey, let's match any word character. Word characters are those characters that you would use for writing a variable, like my_var. Right? And we can zoom in and see how each of them are broken up. It's looking for each thing individually. So it's any letter, any number, any underscore. Yes?
What are we doing this in? What is this?
Regexer, because it's just a good way to visualize it. And again, that website is regexr.com. Oh, that's another cool one. Notice I put in that dot and it turned orange here. I wonder if that means it's a special character. It is a special character. Remember that wildcat question I had on the practice exam where I was looking for where CAT, but I was looking for where the C and the T could be anything, right? Cat, cut, cot, right? The C can be anything. Sorry, the A could be anything. The period doesn't actually match a period. If you want a period, you got to escape it to look for a period. The period actually is a fun character. It is the wildcard character. It says, hey, this letter can be anything. Pretty useful here. Okay. There's a few other characters that have special meanings. The plus and the question mark and the star have all special meanings, but we'll encounter them as we go. Okay. But we were on this, the /w. We also have some other useful ones, one of which we're going to use today. for looking for social security numbers, which is /D. And /D matches any digit. Right? Any /D, lowercase d matches any digit. We also got ourselves a final one. So we've got 3 of these slash characters. That's a lie, but you'll see what I mean. But we've got basically 3. The other 3 are really easy to remember. /S. This one's kind of useful. It stands for white space. Let's go ahead and show that right there. So it's matching my tabs and my spaces. Very useful. Spaces, tabs, line breaks. Very useful thing there. Now, I mentioned there were 3 others, but they're actually the same ones, just inverted. So here we've got /W to match every letter character. But if you capitalize it, it will give it the inverse. So over here, /W says everything that's not alphanumeric. So that's pretty much every space, but I mean, actually, let me go ahead and see for a second. Let's go and see Japanese, the Japanese language. We are going to go ahead and grab Nihongo from this, and I'm going to just simply copy and paste that into here, into my test. Because I'm curious as to what it says by, yep. So here, right, it's grabbing the punctuation and it's grabbing Nihongo because those are not alphabetic characters, right? It's looking for letters, right? Okay. Whereas, right over here, it doesn't grab the punctuation and stuff. /D, /D grabs everything that's not a digit. And finally, S for white space. Capital S gives you everything that's not white space. These are fairly easy to remember, and when on your exam, I'll actually be very generous with what I give you in terms of regular expressions. Let's go ahead and actually pull up my recent copy of exam 3. And exams. Nope. Exam. Let's see. We need GitHub, teaching, intro, exam 3. Right? On the back of the page, I actually give quite a bit of information on how to use regular expressions. For instance, this is probably the one command you'll need to focus on for the final exam, and I put it on there, right? And so over here, right, I give you the reminder of what these special characters are, as well as what other things I do. So I am fairly generous with the information I give you for regular expressions. Yes.
Up there, did you mean how about the inverse of all of this?
Yes, I did. I never actually. You know, I'm impressed how quickly you spotted that one. That is a mistake I do need to fix. I'm surprised I didn't fix it last year when it was pointed out to me. Oh well. Let's go ahead. So, all right. Now, with regards to the, with our limited knowledge right here, we can actually start we can actually solve a bit of the problem we already had, which was, how do I look for any social security number? Okay? And a social security number, for those of you not from the US, they look like this. They look like 111-22-3333. So your social security number is a series of 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. These dashes are typical. Sometimes we see them in this format. In fact, where it's all one number, but usually we see dashes to separate them. We'll learn how to deal with that later, but right now we know how to write something that basically will match a social security number, whereas it's not going to match 770-555-1234. That's a phone number, right? For those of you not from the U.S., on TVs and shows, you'll often see phone numbers that have a 555 in this after the area code, right? With the U.S., it's one as the area code, followed by 3 numbers, followed by another 3 numbers. These 3 numbers, the 555, is basically reserved for Hollywood. They are dead numbers. They're used for on TV shows and media when you're giving out fake numbers, right? Because you don't necessarily want a kid to suddenly try to call Mickey Mouse. And then call up a random, unsuspecting, very grumpy Floridian. So how would we find a social security number, right? Because a social security number can have any number, right? And let's just go ahead and think about the Python code without using regular expressions for a second, okay? How would I write Python code that looks through this? In fact, let's go ahead and write some right now. And we're going to abandon this very quickly because it's torture, right? It might look like something like this. Def find socials. Because right now we're just trying to see if something contains a social number security. Removing and redacting, that's an entire other thing. Text. For index in, let's go ahead and say for index in range, len text. You don't need to write down any of this. Please, for the love of God, do not write down any of this. This is torture. It's bad. So what we're going to do is say letter is equal to text underscore index to get the current letter we're looking at, right? We're going to look through each letter. And basically the first thing, and what we have to do, as I see, is this a sequence of 3 numbers followed by a dash, followed by another 2 numbers followed by a dash, followed by 4 numbers. So first thing we have to do is find a number, okay? So we're going to say letter. If letter equals 1 or 2 or, no. Instead, we're going to simply say numbers, right? Our numbers here are, we're going to go ahead and put this up here now, because we need to write down what all the numbers are, and our numbers are, and I can just go across the keyboard, yay, put that into a string, and we'll say if letter in numbers, actually might be, in fact, it might make more sense to do it like this, because we're only going to use this once, okay? If letter in numbers, so if the index of this text is a number, and, right, we've got 3 in a row, and text of index plus 1, and text of index plus 2, oh, wait, I have to do the in numbers for these as well. Right? So it's already getting pretty long. Let's write another if statement. Because now we've checked the first 3 numbers. If text index plus 3 equals dash, and now you can see it's getting very tedious, a lot to write. Oh, and not to mention, we also have to do out-of-bounds checkings and stuff like that. And also, what we're writing is really only ever going to check one social security number and return true or false if it has one, unless we, make sure to save them as we go. Well, it's going to be a whole thing. So, whereas, how do we write a regular expression that identifies social security numbers? /D/D/D for finding the first 3 numbers, right? Followed by a dash, followed by 2 /Ds to find the next 2 numbers. Oops. Followed by another dash, followed by 4 /Ds, right? And that will identify a social security number. Now let's learn how to do this. Now that we have a regular expression, let's learn how to dump this into Python and see how to do this. Save. We're going to go ahead and drop this on the desktop for a second. I'm going to call this not regex, but regex example, right? Import RE. I'm going to say my regex is equal to this string. And one very important thing, this is possibly the only weird thing we have to do with regex, okay? Only weird thing we have to do with regex. I'll explain it later. But we are going to put an R in front of the open quote. And notice that doesn't break anything. Just how, like a bunch of you who have been using ChatGPT may have been noticing that putting an F in front of a string doesn't break anything. Yes, we've noticed that. No, nobody does this, really. R doesn't break, right? Some of these, you can see that putting some letters in front of strings don't break them because this is denoting it's a special string of some way. Here you can just, because you're using, R is for raw, but you can remember R for regex or R for regex. Make sense? Because that's the only time you're going to be using it. So I'm going to identify what my regex is. I'm going to make some text here. Text is equal to, and I'm just going to triple quote here for a reason, and you'll see why. And I'm just going to go into here and just grab this text, right? And you can come up with whatever wild stuff you wanted to put in here, right? Just make a bunch of text, drop a few social security numbers in it. Not necessarily a real one, but stuff that is formatted like 123-45-6789, or possibly 432-21-2111. Sorry if that was yours. It's now on the internet and can't be taken back, right? Again, that's what I mean about these things being pretty insecure. Okay. So we've got this text, and let's say I want to write a program that says, we're not worried about replacing yet. Let's just go ahead and say, let's write a program that finds all of the social security numbers in this string. That's very simple. We can do it actually with one statement. Print, we can do result is equal to RE, which for the package. And this is actually the least efficient way to do it, but it's easy to remember. The other way is about creating regular expression objects and compiling the regular expressions in advance. Just do it like this for right now. It's fine until you get this. This is perfectly fine for our purposes. RE dot find all. Doesn't that sound nice and useful? Okay. And let me go ahead and actually. Now I can say pattern string returns a list of all non-overlapping matches in the string. By non-overlapping, it's saying that it's not really gonna do this. It's not gonna. It's gonna. It will grab. Okay. By non-overlapping, it means once it grabs this, it's gonna as a social security number. It's gonna start on from here. And so it's not going to grab this substring over here as a social security number. Got it? That's what it means by non-overlapping. Okay. Anyway, re.findAll, the pattern, which is our regex, we can probably just call it a pattern instead because that is the pattern we're looking for. And then the text saying, I'm looking for this inside this. Print result. And there you go. That's all three social security numbers that are found in this. Super straightforward to do. In fact, and I want to emphasize this. I do not try to make my finals difficult. I try to hand out as many freebies as possible to the students because I know a bunch of the students just panic and they crash and don't take the freebies. The freebie I'm handing out is basically guaranteed 8 points on one of the questions on the final exam, even if your mind goes blank, because all the questions that the question I'm going to ask on the final exam would be something along the lines of, given a file, create a new file that has the same contents except all the social security numbers are redacted, or all the email addresses are redacted, or all the phone numbers are redacted, or all the health insurance ID numbers are redacted. Okay? Something like that. And only one line ever changes in that. And that is going to be this line where you set the regular expression equal to something. Now, this isn't the code for that. That code uses re.sub for substitute. And we're going to learn, and that's what I'll be focusing on when we get on Thursday. Yes.
I'm printing it and it's just giving me an empty list. It's not giving me a number.
Did you do like text is equal to this? Like, did you set up a bunch of text that had some?
Not a bunch of text, no.
Yeah, set up, you need some test text for it, is what I'm saying. You just need to create some test text for it. Yes?
So I remember when I was studying for test two, the second exam, and I went over the final exam. I noticed just handed a lot of freebies on the test.
You'd be surprised how many people don't take them.
Huh?
You'd be surprised how many people don't take them.
Right, but my question is like, do you like make exam two harder potentially than the final exam?
No. No. See, I think they're all different. They're all equally difficult in different ways, in my opinion. The exam, in fact, I think the final is generally just easier because there's only so many questions. But at the same time, it's harder because it's the final exam. It's more stressful, and you're already exhausted from having taken more finals. The other thing that makes the final exam easier is you get to choose what your strongest areas are, and neglect and skip over things that you might think you're not as good at. Yes.
I tried putting the text and it's still not working.
I'll take a look at it later.
Okay. You also said you said that you didn't name it Regex.
I just called it regex example.py.
Okay. It's for a specific reason.
I didn't want to name it regex or even worse re because you want to avoid the import issue where you need.
Okay, that's probably why.
So, anyway, but right now today the focus is less on doing this, working with Python, and more about learning the syntax in general because the syntax is super useful. Now there is a non-mandatory homework assignment for regular expressions. It is not mandatory; it's extra credit. Okay, extra credit. There's an extra credit homework assignment for regular expressions. Okay, which I'll go over before the end of class. And again, completely optional. It's extra credit. It's just good practice. But a lot of times you don't even need that. So anyway, here we go. So what other things can we do with regular expressions? Well, sometimes we can't really, sometimes the pre-made character, these character cases, what are they called? We can go to cheat sheet here. These character classes, right? And I always get confused. I'm like, it can't be something called a character class. That's like fighter and wizard and rogue, right? So no. So what we're looking for, though, again, it's great because it does have the cheat sheets in here. Here's the cheat sheet. Character classes back. It's got a reference built in. Here's the cheat sheet. Character classes. So you see that basically we have any character, we've learned these guys, but sometimes these guys are not going to be sufficient for what we're trying to do. So instead what we have are the brackets, which was what we saw first, right, on the Wikipedia page for regular expression. When we saw the regular expressions over here, we saw this bracket over here. Ah, stop that. Jeez. Behave. You're easily replaceable. All right. It's not listening to me. Really not listening to me today. I know. I'm blaming the inanimate object for my inadequacy. Okay. Here we go. So the brackets. So the brackets mean any one of the following things in the bracket. So here it was saying any A, E, I, O, U. In other words, any vowel. No, Y is not a vowel. Just acts like one sometimes. It's not. Anyway, so over here we can look at this. Over here we can see this. If we type A, E, I, O, U, close bracket, it will highlight any vowel we have. And so if I wanted 2 vowels in a row, I could copy paste this. Right? Make sense? And if I wanted 3 vowels in a row, I could copy paste that. Although we don't see any here for 3 vowels in a row. Okay. Now, mind you, that can get a bit tedious, but I will get on to how to avoid the copying and pasting problem in a bit. You can do fun stuff with these character classes, right? A, B, C, D, E, F, G, H, I, right? This is all any letter A, B, C, D, E. A, B, C, D, E, F, G, H, I. But these are all sequential. If you want to get any letter between H and I, which is kind of useful sometimes when you're building a big, long character class, is you can do that, which actually reads fairly naturally as A through Z. It's A through I. You typically see this when you're doing something like A to Z to look for any lowercase letter, right? Make sense? So you can use these brackets to make your own custom character classes. Now, just like how with a word character we had /W to match any alphanumeric character, and /W capitalized to do the inverse of that, we also can do inverses over here. So back to A to Z, okay? We can, if we put a caret as the first character, okay, then that caret has a special meaning, which is the inverse, anything that's not A to Z. And so notice it gets these because, again, it's case sensitive, so saying anything that's not a lowercase A to Z. Anything that's a space, anything that's number, anything that's Japanese, right? That matches. Okay. Now, I think that covers all 3 of those. You can, if you really want any letter, you can do A to Z, right? Any of the following. A to Z. And now it catches any letter. And I could say 0 to 9 as well. And if I put a caret at anywhere else, just not at the end, it'll look for carets as well, which will make Bugs Bunny very happy. Okay. So, this is a very useful tool. Again, because this is basically adding wildcards or more expressibility into our just the ability to find text. All right? And you can see how this is a very common issue where you want to find specific strings, right? Where if you want to pull out prices from a document, you would say, hey, I am looking for the $sign character. It's a special character, followed by, well, and then you think to yourself, wait a second. If we see a $sign character, it's going to have, right, this would give me anything that's like $56, right? But this won't catch $720. It catches the 72. That's incorrect. What about $1.73? Right? Doesn't catch that. But fortunately, regexes are fairly expressive. They're not ultimately expressive. They're not. There's a certain limit. A certain provable limit as to what a regular expression can do. The prime example we give for what the limits of regular expressions can do, because at the end of the day, what we are doing is the linguistic equivalent of drawing a flow chart. Okay? What do I in TFA? Deterministic finite automata. We're doing something that's basically as simple as this, We're basically saying, hey, if you see a 1, go this way. If you see a 0, go this way. Yes.
So is it related to the idea of being Turing complete?
Yes, it does. This is on the lower end of that, right? If we look at automata theory, Turing complete languages basically exist in this space. Okay? They exist in this space in automata theory. Whereas whereas regular languages are basically the equivalent to a finite state machine. They're the linguistic representation of a finite state machine. So the idea here is that basically there's a limit to what they can do, but a programming language can do everything a regular expression does and more, right? Obviously, since we're using them in a programming language. Regular expressions have a limit, and that limit is parentheses matching. So, in other words, seeing, hey, are these, for every open parentheses, is there a properly closed parentheses, just like your text editor can detect. And the answer is that we can still handle this. So we can handle this first with the plus operator over here. Okay? And the plus operator is fairly straightforward. The plus operator says that of the preceding character, I want at least one of it. So it matches $5, right? We want a $sign followed by at least one digit. So it matches not a $sign, because that by itself is nothing, but it matches $1, it matches $12, it matches $123, it matches $1,234, and so on and so forth. Right? Now, we're not matching the cents yet, but we can handle that. We can say we want cents, we want the dollar, we want the dot in there. And then if there's a dot, we want 2 digits after it, just exactly 2, right? Because we always do exactly 2 cent. Now, the issue is that this is now blocked this. Fortunately, we can use parentheses. Parentheses allow you to treat everything as one character. And so we've learned about the plus, which says at least one of. Now we're going to learn about another one, which is called the question mark. The question mark says, hey, the preceding thing in front of me is optional. Right? The single object in front of me, either being a single letter or a group of characters in parentheses, that's optional. It literally says 0 or 1 of, right? That's a fancy mathematical term of saying it's optional, right? So now we can see that it matches basically any kind of string that we need, whereas it's not being overly permissive. It's not giving me invalid strings, right? It's not going to match $7, although it will match this dollar portion of it. So there are limits. You can make these things rather complex, although there is a limit to the madness. Sometimes sometimes it is not always. Sometimes just because you can doesn't mean you should. Let's see. Yeah, email regex.com. The email address regular expression that 99.99% works. And according to the RFC request for comment official standard for email addresses, this is the regular expression that works on 99.99% of all email addresses. Here's a flowchart if you need it. I can't read it. It's a monster of one, and it's using some special. It's checking for at least one of special hex codes. It's got all these series of possible digits and optional things. And then you get an at. So this is everything before the at symbol, and here's everything after the at symbol. It's a nightmare. Well, like I said, just because you can doesn't mean you should. If I ask you to write a regular expression, if I ask you to write a regular expression to check email addresses, it will be to remove specific email addresses, like remove the TU at Temple email addresses, but leave like things like a Gmail address untouched. Right? That makes sense? That actually was a question I've asked on the final exam before, where basically I've asked you to where I ask you to find something, write a program that removes, how much time do I have? All of these kind of things. Remove emails that look like this. Here's my TU email, tug85861 at temple.edu. But only remove emails that are of this format. So my andrew.rosen alias at temple.edu. And if you haven't set up an alias and you're just still using this, you really should set up an alias. It's much more professional looking. Or my personal Gmail address, because that, or temple.edu, which is profandrewrosen@gmail.com. You can see even though that's my personal email, I don't really care about that one. Some interesting notes about Gmail addresses, by the way. First off, the dots don't matter in a Gmail address. This is the same email address, and so is this. Okay? Another fun fact of things you can do with email addresses, you are not necessarily aware of all the valid characters that exist for email addresses. For instance, plus is a perfectly valid thing in the beginning of an email. In fact, Google uses the plus a lot. So when I register for things in music, I'll do plus music. And if it's an email address I think is going to sell my something to spam, I might do this, which lets me know that this company handed it out to a spam address or whatnot. I might go spam 123 or something like that, and it gives it an identifier to let me know, oh, did this company sell my email to someone else or share it with somebody else? It's a kind of useful thing you can do. Just neat tricks, also slightly useless tricks. Anyway, so yes, we've learned about the $sign. We've learned about this plus operator, which says at least one of the thing. This says 0 or 1, or it's optional. Finally, we have one other thing called the clean star. And I say clean star, and you're hearing clean, but what I'm saying is clean. Okay, that's what I'm saying. Okay, the clean star, you know what it looks like. It's this. It's the asterisk. But in regular expressions and regular languages, it has a very special meaning. The clean star, so here we have $1.70, all right? Occasionally, if we say, now for 70 cents, we have a few different ways of writing 70 cents. 70 cents might be written as 0.70, but you've probably also seen it written like this. Right? Now, how would I capture this? And the answer is, rather than doing at least one of the following, we can do this. Now, the clean star over here is very, very, very similar to the plus operator. The plus operator says at least one of the following. And the clean star is very important, but it does something you don't necessarily think of or ever use in everyday language, which is at least 0 of the preceding thing. This is a very useful thing because it's a way of saying it's optional, but if you have a lot of it, there's a potentially unlimited number of it. Of course, now, this does get into the issue of the fact that this gets recognized by itself now because it's saying there's a $sign followed by at least 0 digits followed by that. And so sometimes it's a game of whack-a-mole sometimes the clean star isn't the appropriate tool to use. You can actually make these regular expressions fairly complex. And I do my best to try to avoid making them complex. For instance, we've set to here, one thing we could do is add the bar, which is, if you're from other programming languages, you already know what the meaning of a bar is. It means or. So, very boring thing. It says, hey, match a dollar sign followed by at least one digit, optionally followed by a bunch of this stuff, or an A, right? So, but now, this gives us an idea of, wait a second, I could copy paste this and modify it a bit. Or I can say, right, it's $1 sign, it's a dollar sign followed by a bunch of stuff, optionally followed by a bunch of stuff, or a dollar sign that's definitely followed by a single period and 2 digits. And now we match all these things without matching the blank dollar sign. There's different ways to do everything, and it's pretty cool. These things are extremely expressive. All right, there's one other thing I need to tell you about before I, yes?
How would you go about making this more,
What?
like, as a novice programmer, how would you go about making Regex more like because
That's the neat thing. You don't. So you don't make these things more readable. You build them up slowly. Unfortunately, regular expressions are one of those things where they go out, where that thing I've been talking about, readability, goes out the window, unfortunately. Readability was not the priority of regular expressions when it was in development. It was definitely the conciseness. Although, now that I actually give it about 2 seconds thought while I'm talking, if you do want to make it more readable, remember you're constructing strings. So there's nothing that's stopping you from saying, from basically splitting it apart, right, and then concatenating it together, right? You could say, like for here, right, that is equal to right, like that. And then you could concatenate them together, and then you could create multiple variables and concatenate them together into the regex. So you could build it piecemeal, right? So, because we're working in a wonderful programming language, and we can do it like that. Okay? So, contradict myself from a minute ago. It is possible to make these things more readable. You don't often need to. But you can, because you're working in a programming language. Now, the last part I want to say is, let's go and just do a really stupid, easy example. Here's a bunch of ha-ha-ha-ha-has, right? Or actually, let's do a fun one. Banana. Banana, right? I often say that the issue with spelling banana is not spelling it, but stopping spelling it. Okay? Okay, so let's go ahead and see this. Banana, right? Now this is a good example because we can take a look at this na over here, right? And just look at the na. The na is repeated in banana and banana na 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 na, right? Okay? You can specify the exact, so we learned how to do, okay, I'd like at least 1, I'd like at least 0, this is optional, as well as, oh, and by the way, even though this part was optional, it does match it because regular expressions are greedy. So when it's given the option to match versus not match and still work, it will try to match as much as possible. Okay? So we learned about those, but we can also use the curly braces here as to do what's called a quantifier. Here, I can say I want exactly 2 nanas, or 2 nas, right? I want exactly 3 nas. So you notice over here that banana doesn't get highlighted, but banana na does, right? Same with 4. Okay, this is actually a fairly nice example, right? Ba is not any affected by this. but because we're treating NA as a single character here due to the parentheses, banana. Single token is probably the better way to put it. Now, you can do fun stuff but with this as well. Just like you can use the range function, we have commas. So this says anywhere between 2 and 4 bananas. Those are 2 and 4 nas in your bananas. Right? So it matches banana and banana, right? If you leave off the end, this means at least 2 nanas, right? At least 2 nas. You can tell I'm having way too much fun with this. All right, I'm very easily amused. And on the flip side, let's see. Can you do it the other way? Doesn't appear like it. At most 4, no. You can do 0 to 4 though, and say at most 4. Okay. So let's take a look at the extra credit homework really quickly. Okay? Sorry? I have 4 minutes. Plenty of time to take a look at it. It is a longer homework, but it's not, it's fun, I like to think. And some of the answers aren't necessarily easy to get or easy to write. And a lot of times I'm just trying to get you to think about especially on that first page, I'm just trying to get you to make your best effort at it, okay? Because it is tough, okay? So let's look at modules. Or let's go and look at assignments over here because I don't think it's under modules. Okay, and if I look for assignments, Regex. Let's see. Oh, I did it as an in-class exercise. Let's go ahead and say, no, I don't know I have time to do this as an in-class exercise, so I'm going to modify this. We're going to modify this. We are going to make this worth 30 points. Assignment will be an extra credit assignment worth 30 points. And what I do for that is I'm going to just simply put a big fat 0 here as the number of points it's worth. And so if you complete it, you'll get 30 out of 0 points. And that just simply gets added on top of all of your grade. Make sense? So, and that will go into your demoed lab assignments grade, which is a pretty nice place for that to go. Okay, so let's take a look at the PDF. Because last year I did this as an exercise. So, hint, maybe look at last year's recording and you might be able to do some of these. First one, I give you words.txt, a dictionary file, a spell checking file essentially. And I want you to basically answer some words. Some of these can be answered with regex. But do try to use regular expressions to figure out how to just get a hang of it, such as 4-letter words are supposedly naughty. How many 4-letter words are there? I'm scared of pyramid schemes and MLMs. How many words contain hun in them? That's a rather obscure joke. Do more words end in ing or ion? Okay. How many words contain a Q not immediately followed by a U? For instance, this is words like the country Iraq. Okay? So how many words have no vowels? How many words are only vowels? How many words are contracted with not, meaning they end with actually, got to fix that, that is N''T. How many words with 2 vowels in a row are there? How many words with at least 2 vowels, but with not adjacent? And then some other ones that are taken from from a textbook, the automate the boring stuff. If you need more information on how to do this textbook is linked to in the syllabus. Automate the boring stuff with Python. You want to look over here in chapter 7, and this will go over all the stuff. This is a free textbook. Free online. Hard copies like 20, 30 bucks. It's pretty good. He makes a lot of RoboCop jokes. So, all right, take care. We will see how to solve some of the problems using substitution on Thursday. Thursday will be online over Zoom. So we will be doing a class on Zoom on Thursday, and I will also release you early that day. So I will make an announcement to make sure that we all remember.